Welcome back, everyone. Now we're going to talk about another example of present value of an annuity. Here's an example. So the annual interest rate on a credit card is 13.99%. If a payment of $100 is made each month, how many months, so that's important, will it take to pay off an unpaid balance of $2,489.45? Assume that no new purchases are made with the credit card. Okay, so we're going to be using the present value of annuity since we're given this is the loan amount, this is the interest rate you're going to get, and you're making payment of 100 every month. You want to know how long will it take to pay off this balance. So the formula I'm going to be showing you is this one. P, which is the present value of some annuity, is equal to big R, which is your periodic payment, in this case is the monthly payment, times 1 minus parentheses 1 plus little r over n to the power of negative n times t, parentheses all over little r over n. So in this formula, we're going to be using P to be the loan amount or the unpaid balance, and the little r is your interest rate in decimal. And then big N, the little n, it's going to be the compounding period. So this is the number of compounding period. And in this problem, it's going to be 12. So this is always compounding period in a year. And big R is going to be the periodic payment. In this case, this is going to be a monthly payment. So we have everything we need, and also T. So the T that we're using in this formula, this is time, but the units you're going to get, it's going to be in years. So we'll have to convert it back to months later because that's what the problem wants. Okay, so let's substitute everything we have. So we know our principal amount, or the present value, or the loan amount, however way you want to interpret it, that's going to be $2,489.45. The interest rate we're getting is 13.99, so that's in decimal 0.1399. And N in this problem, that's 12, compounding every month, and periodic payment, that's 100. Time, that's what we're looking for. So let's substitute. So we have our P value, that's 2489.45, is equal to 100 times 1 minus 1 plus the rate, that's 0.1399 over 12, divided out times to the exponent of negative 12 times t is what we're looking for, close parentheses, all over the rate, that's 0.1399 over 12. So that's how you set it up. Now you want to use a calculator so that you can do the calculation here. Let's go ahead and do that. So I'll be using a calculator to calculate this. So I will first figure out what this number is. So that is going to give me about 0.01165. So I'm going to multiply that to the left-hand side. So you'll have 2489.45 times that denominator. So that would be 0.01165,833 is equal to 100 times 1 minus, and then here I'm going to add this up and then raise it to the exponent of negative 12t. So that's going to give us 1.01165,833 to the power of negative 12t. All right, so that's what I get so far. Just do it very carefully since it's very easy to trip off. Now I'm going to go ahead and perform this multiplication. So this would give me about 29.02283,792 is equal to 100 times 1 minus 1.01165,833 to the exponent of negative 12t. And now I divide both sides by 100 to get rid of this. And that's going to give me 0.2902283792 is equal to 1 minus 1.01165,833 to the exponent of negative 12t. And now I'm going to go ahead and I can subtract 1 on both sides and multiply everything by a negative 1. So that way I have a negative value. So that's going to give me about 0.79. I believe this is 0.709. 77162 is equal to 1.01165,833 to the power of negative 12t. So I subtracted 1 on both sides, and then I multiplied by negative 1 to get rid of that. That's what I get now. And now I'm going to go ahead and take logarithms. Since the variable I'm solving for is an exponent, we need to bring it down, so we'll apply logarithm on both sides. So you'll have log of 0.709776162 is equal to log of 1.01165,833 to the exponent of negative 12t. And now, of course, by laws of logarithms, we can simplify the right-hand side. So you'll have negative 12t comes forward. And now finally, we're solving for t's right here. It's multiplying the numbers, negative 12 and log of 1.011, all of that. I'm going to go ahead and divide by that on both sides. So that would give me t is equal to log of 0.709776162. Divide that by negative 12 log of 1.01165,833. And then after you put this in your calculator, you'll get a value of about 2.464. And now this is in years, of course, so be mindful of that. Now, since the problem asks us how many months it will take for the balance to be paid off, so we're going to convert it to months. To do that, we're going to take our value in years and multiply it by 12. So I'm going to take this number and multiply this by 12 because there are 12 months in 1 year. So the unit year will cancel, and then you'll have your final answer in terms of months. And if you do that, you're going to get about 29.57 months, which we can say roughly 30 months. So it's going to take about 30 months to pay off the loan. All right, I hope this makes sense. Take care, everyone. See you next time.